Alright, it's your favorite YouTuber Gastra, and welcome! Today, this is just a small one-off video where we're going to talk about the size of things on your computer. Starting from the least to the most. This is going to be a short video because I only have 4 things on the line. Well, it's 5, but first are the bits. Each bit is a component of your computer. It is a 0, that looks like an O. It is either a 0 or a 1. I do not know how to draw on paint. I should draw a line between these. So, basically, your computer is made up of bits besides the physical part, like your mouse pad and keyboard, and if you're a laptop user, the back, thing that the keys are on, but we don't have to worry about that. So basically, that's kind of it. However, you can compare this to real life. However, this is a gosh, how do I not know how to draw a B? Is a base 2 number system. This base 2 number system means that you would do 0, 1, 1, 0, 1, 1, 1, 1, 0. No, wrong thing. Sorry. Sorry. Base 2 is a little confusing because we use base 10. A number system that has all your favorites: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But down to the not just atomic level, the quarkic level. You can skip this part of the video if you want. There is a base 3 number system. Quarks. Basically, remember what you've been told. Atoms can't be split down any further. Well, they lied. You can split them down into quarks, which are the true smallest building blocks. Now, they're not the smallest thing, just the smallest physical thing. The smallest thing is the Planck length, which is really, really tiny. So, next we will move on to an int, short for integer, which is a number. But this isn't just any number. It has to be within a range of -2 billion and 2 billion. Not those exact values. It's like what you gotta get to it through multiplying 2 by 2 over and over and over again. Basically, it's 2 to the power of 32, so you're multiplying 2 by 2 32 times. So if you want the exact number, standard 2 to the power... No, I don't want it squared. 2 to the power of... How do I do to the power of? No, stop squaring. 2 to the power... How do you do the power? Why did it just become 0? 2... Isn't it scientific? Yes, this is what we need. So 2 to the power of 32. So this is an unsigned int. This this is half of an integer. It's a number that ranges from 0 to this number. A normal integer ranges from negative half this number to half this number. So, that's our first item. Complete. I should put check marks on these. Again, this is just a one-off video. I'm not being very serious. And now, we've got strings or stirs. Basically, every single character in a string is 8 bits. What is a string, you might ask? It's just a word. Not just a word. It's just text. String is just text. But if you put down 4 numbers surpasses an int or integer. So 4 numbers, I meant characters. So that's basically it for the string. Now we move on to the biggest 2 of them all. First, the image. I need to add an 8 here. Yes, perfect. Now, every pixel in an image has 3 color values. I'm gonna start using this text. Look up. Why is this so hard? This is basically it has free bytes. Now we skipped over bytes. It's just 8 bits. That's a quick explanation. So these each go from 0 to 255. However, this is for color value. So for example, I will put the text in the color that the text would make if it was an RGB value. Can you move it? So we've got red, green, note that you cannot set these values to above 255 or below 0 because first, a byte can't store that. And also, your computer screen would get way too bright and you would be blinded, probably. Hold on, is the sun brighter than your computer screen? 0 and this. But there's one more. I am going to put it on a black background for a reason you are about to see. It is 255, 255, 255. I need to make this text smaller. Change this to 55/255/2. This is the color white. And that's basically it, and that's almost it for images. But they have to do this for every single pixel. Let's assume you're making high quality pixel art as a middle ground between 16 by 16 pixel art and like hand drawn 256 by 256 vector art. Again, that is 24 bits per pixel. Then 6 times 64 times 64. This is how many bits it takes. Now we can divide this by 8 to get this. This is our amount of bytes in here. Then we divide this by 1024 to get 12 megabytes. Every single 64 by 64 image you have is 12 megabytes. A megabyte is just 1024 bits. I mean bytes, not bits. Sorry. So we've crossed off image, but now the final one. Video. Basically, it. So we have to do this 24 again, but I have no idea how to change the recording quality of a video. And if you don't know, like me, it is stuck at 120 at this at 1090 and and 1080, which makes this number of bits. First we divide it by 8, and then we divide it by 1024. There is now a decimal. There is now a decimal. This is still over. Wait a second. How is this a gigabyte? Anyway. Then, divided by 1024 makes 3 gigabytes per image. And then, you have to multiply that by 60 for the frames, and then we'll assume you're making a 15-minute video. So this is how many gigabytes it has. Wait a second. What? This is setting off alarms. A video is not this big. Are my calculations wrong? No, I did everything right. Anyway, just don't ever watch the calculator part again. And we're done. Let's put a yellow question mark next to video. Anyway, I hope you enjoyed, and I will. I'm sorry. Why was I doing that dramatic pause? And I will see you. Why is my outro taking so long? And I will see you next time.